Hi, in this video, I'm going to discuss about non-parametric test. Okay. In the previous video, we tested hypothesis about mean variance. It could be one sample test or two sample test, t-test, g-test, those chi-square test, and so many other tests, right? And most of those tests require the sample to be taken from normally distributed population. Okay, and we also discussed how to check the normality of the population from which a sample is taken. Okay, there were several ways to do that, and also we discussed at the end of the last chapter that if the population from which the sample is taken is not normally distributed, or if it is slightly deviated from the normality, then what we do is we try to change that data using the data transformation, right? Some of the transformation we discussed is logarithmic transformation, okay? Also we discussed about inverse sine transformation, square root transformation, square transformation, and so on, okay? Now, if the population still violates the normality after transferring the data into so many possible transformation, then what we do is the hypothesis testing that we used before, which is also called parametric test, that requires the population to be distributed normally, then that test may not be very good to use. Okay, in such situation we use slightly different test that does not require the normality of the population, which is called non-parametric test. In short, we call NPT. Okay, so the parametric test have requirements about the distribution of the population involved. Okay, for example, the unpaired t-tests are based on the assumption that the data are sampled from the population with normal distributions. Similarly, for the paired t-test, the difference between the paired values are sampled from normal distributions. Non-parametric tests do not require that sample come from the population with normal distribution or any other particular distributions. These tests are still useful when there are outliers too. The non-parametric test can be used in wider situations because of the flexibility of distribution, and the non-parametric test can be used with data consisting with ranks and categorical data such as gender, colors, etc. Okay, so the distribution should be normal. That assumption was used only for the numerical data or the quantitative data, right? But non-parametric test can be used for the categorical data too. Okay, we discussed the same type of question. What are the same type of question? For example, the average of the population or the median of the population is equals to some number versus less than or greater than or not equals to. Okay, so all those two means are equal, meaning the two central values are equal. Versus that was in the parametric test, but in the non-parametric test we will deal with the medians. Okay, the medians of the two populations are equal or non-equal or greater or less, and so on. Okay, guys. All right, so in the non-parametric test, the numerical data are reduced to qualitative form, so it may lose information of the data because all these data, the numerical data too, they will be reduced to the qualitative form by using the ranks. Okay, the results from non-parametric test may not be as strong as the one from the parametric test, but when the requirements of the population distribution are satisfied, then non-parametric tests are generally less efficient. If the normality is not violated, always use the parametric test you used before. Okay, but if the data or the population is severely deviated from normality, then the parametric test may not be strong enough compared to the non-parametric test. In that case, but when the assumption of the parametric test are violated, the non-parametric tests are more efficient. Okay, Some assumptions like the sample data come from random selection is the common assumption in both of the parametric and non-parametric test. Okay, so let us talk about first of all, let us talk about the ranks. How do we rank the data? And we'll discuss different type of test in non-parametric test. Okay, so there are various non-parametric tests to test the hypothesis about central values, and most of them use the ranks of the sample data. Okay, what is rank? A rank is a number assigned to an individual sample item according to its order in the sorted list. The smallest item is assigned rank 1. Okay, if there are data points, you just write the data points in the increasing order, and then you assign the rank in the increasing order too. For example, the smallest data will be denoted by 1. The bigger number after the smallest data will be denoted by 2, and bigger by 3, and bigger by 4, and so on. Okay, in non-parametric tests, data are sorted when they are arranged according to some criteria, such as smallest to largest. After ranking, the actual measurements are not used again in the test. The actual data will not be used, only the rank will be used. Okay, if the data set has outliers, the non-parametric tests are particularly useful since the ranks are not unduly affected by the outliers. For example, when you assign the ranks, if some data are like very big or very small, we don't have to worry because it's just one rank above or one rank below the other data, right? So you should not be worried about that. So this non-parametric test is still valid, works well in case of the outlier. Okay, so when you assign the rank, sometimes you will have 2 or more than 2 data with the same values. Okay, so if there is a tie in the ranking, see, so for example, look at this data set, the order data, that was a random data set, and I put them into the order form, meaning I sorted them in the increasing order. Now when you sort them in the increasing order, the smallest one is 1, right? And then what is the bigger number after 118? There are 3 121. So how do I rank them? Basically, if they were different values like 120, 121, 122 like that, then you would assign 2, 3, and 4. So these are the position for rank 2, rank 3, and rank 4, but they are all equal. So how do I assign the rank for that? Is you add the rank of those 3 numbers, 2 plus 3 plus 4. These are the rank of those 3 numbers. Divided by how many number are there? 3 number, right? 121, 121, 120. That is 3. If you do that, you will get 9 over 3 is 3. So all of them will have the equal rank because they were equal numbers, right? So the first one is 1. The second, third, and fourth will be 3, 3, and 3. Now what we do is you rank the next number 5. Why? Because we ranked already 4 numbers already. So this number should get rank 5, this number 6, this number 7. These 2 numbers are equal, although they were the position of the rank. For these 2 numbers, this 136 is 8 and 9. So I find the average of 8 and 9. 8 plus 9 divided by 2. That is the average. So that is 8.5. So both of these 136 will get 8.5 and 8.5 as the rank. Now this will not be 9, this will be 10 because these 2 actually were 8th and 9th place, but we assigned the number 8.5 because they were equal, because they were tied, and then the next one will be 10th. So this is the way how we assign rank for numbers if they are repeated or non-repeated values. Okay, now after we talk about the rank, what I'm going to do here is I want to talk about one of the very simplest type of test, non-parametric test. This is called Sine Test. Okay, so this is the Sine Test. So what is Sine Test? The Sine Test is a non-parametric test that can be used in place of one sample t-test. It is similar to the one sample t-test. What does one sample t-test do? It says the data or the average of the data is equals to some number versus the average of the data is less than some number, left tail test, greater than some number, right tail test, or equals to some number or two tail test, right? So similar to that, instead of the average, we will be talking about the median here, okay? So, or the paired t-test, because paired t-test and one sample t-test are equal. Only the difference was in the paired t-test, you find the difference of those pairs and then use the one sample t-test for the difference. That's what we did, right? Okay. So, in case if the data are seriously deviated or if the data set are violating the normality test, then you can use the Sine test if the test is one sample or if the test is two sample with paired test. Okay. And when the normality assumption of those tests cannot be met, the Sine test assess whether the median of the population equals to a null hypothesized value. Okay. We analyze the frequencies of positive and negative signs to determine whether they are significantly different. Okay. So how do I do that? You will see. So what are the steps first? So the steps for the Sine test are given as these steps. Number one, write H0 and H1. So how do you write that? In the one sample test, you write H0 is mu d. What is that? That is median equals to some number, versus median is greater than some number or less than some number or not equals to some number. So these are the alternative hypotheses. Right tail, okay, and then left tail, and then this one is two tail. So this is how we write the null and alternative hypothesis, right? And so this is H1. Now, if it is two tail, one sample, if it is two sample test, then what do? Is you do H0 is, see, we write mu d, or the difference between the two medians. Okay, so you can write mu d, that is the difference between the two medians, is equals to 0 versus less than 0, greater than 0, not equals to 0, similar to that one. Okay, so two sample, paired two sample, I should say paired two sample. Okay, if the samples are not paired, we will use different tests which will be discussed later. Okay, and what you do next is assign positive and negative sign for the difference. What do? Suppose your test is mu d equals to, let's say, 47. In this case, what you do is all the data, you find out the difference of all the data. So every data minus 47. Okay, so data 1 minus 47, data 2 minus 47, data 3 minus 47, minus 47, and so on. Okay, and then you check the sign there, and then you check the sign of these. So is this positive, is this negative, and so on. And you write, if it is positive, write positive, if it's negative, write negative, positive, and so on. And you will count how many are positive, how many are negative there. Okay, guys, all right. So assign positive and negative sign for the difference. Also ignore any zeros. If there are any zeros here on the, when you find the difference, you don't count that. Only you list the positive and negative signs. N is the number of positive and negative sign. Okay, so now if n is less or equals to 25, the test statistics is t equals to x, the number of less frequent sign. What does that mean? If the total sample size is less than 25, okay, then in that case the test statistic is x. What is that? X is the less frequent sign. So if one is repeated more than the other sign, then the less repeated sign is the value of x, which is the test statistics. The critical values are found from the Sine test. I will show you what is Sine test table. N is the sample size or the number of pairs. So n is again the number of pairs, right? Because you will have in the one tail test, n is the sample size. In the two tail test, the n is the pairs. Basically, it is the total, I should say total number of positive sign, negative sign, and 0. That is n, right? Because where n is the sample size or number of pairs. Because you should be counting 0 as well when you count n. But when you find out x, or when you count the positive and negative sign, you ignore 0. Okay, we'll see example. If n is greater than 25, the test statistic is g equals to x plus 0.5 minus n over 2 divided by square root of n divided by 2. The critical value are found using G table. For n is greater than 25 case only, okay? Or use the test statistic to calculate p-value. And if t is less than the critical value, when you are using the critical value method for n is less than 25, if t, the test value, is less than the critical value or p is less than alpha, reject the null hypothesis. Otherwise, fail to reject the null hypothesis. Okay, that's what we do here. All right, so what I'm going to do next is I am going to give you one example. This is the Sine Test critical value table. I will be doing both methods. One is by hand and the other manually, and other I will do by using R directly. Okay, guys. All right, let us talk about this example. So Sine Test using the matched pair. Okay, guys. So let me read the question first. All right, let us look at this example. Okay, it says matched pair example, which is Sine Test. Consider a clinical investigation to assess the effectiveness of new drug designed to reduce repetitive behavior in children affected with autism. If the drug is effective, children will exhibit fewer repetitive behaviors on treatment as compared to when they are untreated. A total of 8 children with autism enrolled in the study. Each child is observed by the study psychologist for a period of 3 hours, both before treatment and then again after taking the new drug for 1 week. The time that each child is engaged in repetitive behavior during each 3-hour observation period is measured. Repetitive behavior is scored on a scale of 0 to 100, and scores represent the percent of the observation time in which the child is engaged in repetitive behavior. For example, a score 0 indicates that during the entire observation period the child did not engage in repetitive behavior, while a score 100 indicates that the child was constantly engaged in repetitive behavior. The data are shown below. Okay, so these are the before treatment. The first child shows 80% of the time he was showing the repetitive behavior, and before treatment and after treatment he was showing that in 75% of the time. Similarly, fifth child was showing 80% versus the 20% after the treatment, and the last child was showing 20% before the treatment and 25% after the treatment. So we want to see that is the drug is really helping to reduce the repetitive behavior of the children with autism or no. Okay, that's our goal here. So what we need to do first is these two data are from the same child, right? And these two data are from the same child too. So this is the paired, because these are the dependent sample, right? These are the paired test. What we need to do is we need to find the difference. 85 minus 75 is 5. Is it positive or negative? That is positive, right? Similarly, the difference of 70 minus 50 is 20, positive. And you just write the sign for the difference. If it is positive, write positive. If it is negative, write negative here. Okay, now what is the test value? Or first of all, what is n here? So here, n is the number of pairs, right? N is number of pairs, so that is 8. N is 8, which is less than 25, right? So when n is less than 25, what do we do? The test value or the test statistic is the number of less frequent times. Okay, that is here how many? So there are more positive than negative. So 1, 2. So x is 2. Okay, by the way, this example does not have the difference equals to 0. If the difference is 0, you do not count that on x. Okay, so because it will not have any positive or negative sign, you just write blank there. All right, now what is 8-0? Treatment has no effect, meaning the median of the difference is 0, versus H1 is there is a difference. The median of the difference is not 0, and alpha is not given here. Alpha is not given, meaning that every time when alpha is not given, then you will assume alpha equals to 0.05. Okay, now The test statistic is n is less or equals to 25, and thus the test statistic is x equals to 2. So we do not need to convert to the g value. You see that? This step says that if the n is greater than 25, if the number of pair of the data, or the number of differences, you can see, is greater than 25, you need to find out the g value. But here the number of pair is 8, so you don't need to change that into the normal g value. So we don't need to convert to the g value. That's what it says. Okay, now critical value. Since the n is less than 25, we use that table to find out the critical value. Okay, from the Sine Test critical value table, the critical value for alpha equals to 0.05, and it is two-tailed test, right? So two-tailed test, alpha equals 0.05 and n equals to 8. Look at that. So n equals to 8, right? This is n equals to 8. Two-tailed test, alpha equals 0.05. So what is the critical value? Critical value is 0. You see that? So for two-tailed test and n equals to 8, alpha equals 0.05. This is the two-tailed test, alpha equals 0.05. So you see that the critical value here is 0. Critical value is 0. And as we mentioned in the methods, you see that if the test value is less than the critical value, then we reject. But if test value is greater than the critical value, then we do not reject. See, since the test statistic is greater than the critical value, we fail to reject the null hypothesis. What was the null hypothesis? Treatment has no effect was the null hypothesis, right? Hence, what we can say is we do not have sufficient evidence at alpha equals to 0.05 to show that there is an improvement in the repetitive behavior after taking the drug as compared to before taking the drug. That's what we can conclude from here. So let me do these things in R. So let us do this. So X is 85, and then 85, 70, 40, and I copied that X for the before treatment. Y is C, and again, so you can write this symbol or equal to symbol, no problem, right? No problem there. Okay, so you did that, and then write down C and then copy the data, all this data here. Okay, by the way, to use the non-parametric test like Sine Test and other tests, you need to install package called BSDA. So you can run this code, okay? If required, install package BSDA. So it will check if the BSDA is already there or not. If it is not there, then you will install it, okay? If it is already there, then it does not install, all right? All right, so I'm running this X and then Y, okay? Now, see, this is sine, all uppercase, sine.test. X comma Y, alternative is two-sided, and confidence level is 0.05. This is the dependent sample matched pair Sine test. Okay, so what do you get? You get that, what do you get for alpha? Alpha is, p-value. P-value is 0.2891. That is the p-value. Okay, so the p-value is 0.2891. So since the p-value is greater than alpha, we do not reject 80. So there are sufficient evidence that the median of the two data sets are equal. Okay, so the effect of the drug is not significant. In the reducing the repetitive behavior, right? In reducing the repetitive behavior. That's what we can say here. Okay, now, so if it is one sample test, okay, if you want to test if the median of a number of repetitive behavior before treatment is equal to 70, if you want to just test the hypothesis for this one sample only, okay, so if you want to show before the treatment the number of repetitive behavior is equals to 70 versus not equals to 70, then is what you do. Although Sine test requires two inputs, X and Y, if there is only one sample, you do the other sample equals to null. Okay, so X comma Y equals to null, mu is 70, because we want to do one sample test, mu equals to 70 versus mu not equals to 70. Alternative is two-sided, confidence level is 0.95, and you do that, what do you get? in that case, your alpha value is small, p value is 0.007. That means p value is less than alpha. You see that? P value is less than alpha. Hence, what you can say is basically, you can say that we reject the null hypothesis, right? So there are sufficient evidence that the median is not equals to 70. So you can do one sample t-test this way, or one sample Sine test this way, or two sample Sine test with matched pair this way. Okay, if the pair is not matched, meaning that if two samples have different sizes, and if they are independent sample, then we use different test. Okay, so which we will discuss later. But let me do one more example on that. Among 945, so this is the nominal, this is the categorical data. Okay, the previous one was qualitative data because the data was given in numbers, right? And this one is the categorical data. So let's talk. Among 945 couples, we use the X-sort method of gender selection. 879 babies were born were girls. Suppose alpha equals to 0.05. Use the Sine test for the claim that the X-sort method increases the likelihood of baby girls. That's what you want to test. Okay. So P equals to 0.05, because if the X-sort method does not work, then the probability of baby girl or baby boy is just 50%, right? Meaning if there is no effect. But if there is effect of X-sort method, and if that is beneficial, that method is good for picking the girls or selecting the girls, okay, then the probability of getting the girl must be greater than 0.5 after the X-sort method, right? Now, what you do is denoting the plus sign for girls and minus sign for boys. There are 879 positive sign and 66 negative sign, and as before, we denote X is the smaller of those two signs. Okay, so that will be X equals to 66. But you see that here what you got is n is greater or equals to 25. The sample size is greater or equals to 25. So what we don't do here is the critical value or the test value is, we don't do that way. What we do here is basically so we don't find out the critical value by the Sine test table. What we do is we need to change that into the G value. Since n is greater or equals to 25, we need to convert the test statistic to G. The new test statistic is G equals to, we'll use this X though, okay? So G equals to X plus 0.5, that is 66 plus 0.5. So X is that 66, right? 66 plus 0.5 minus n over 2 divided by root under n over 2. So what will be n in this case? Basically, so what is the value of n? So here the value of n is basically the total sample size here, okay? So this is not like a pair, so that you count the pair. No, there is no pair thing here. So that is n is the total sample size, so which is 945. So X is 66. So X plus 0.5 minus 945 divided by 2 divided by root under 945 divided by 2. If you do that, you get negative 26.41. Okay, guys. So I have done that thing here. So X is 66, N is 945, and G is X plus 0.5 minus N over 2 divided by square root of N over 2. So when I do that, let me show you. So when I do that, I got Z is negative 26.41. Okay, this is what you got. Okay, now, so what is the p-value? P-value is the 2 times the area left of G, because G is negative here, right? So 2 times the area left of G. How do I do that? Is you can actually do 2 times the p norm, negative 26.41, and then comma 0, comma 1. If you do that, you will get almost 0. Let us see what we get here. So we got p is equals to 1.05 times 10 to the negative 153. It's a very, very small number, but positive. So we got almost 0 there. So p-value is less than alpha, means we reject the null hypothesis. So what we can conclude is thus there are sufficient sample evidence to support the claim that the girls are more likely with X-word method. Now, let's see this note. Sine test has very little power compared to the one sample or two sample t-test because it discards the information about the data. It just finds out the sign of the difference, right? So it doesn't care. It does not care the exact value of the data, right? So for example, a measurement that is just bigger than or very large from its hypothesized mean are both denoted by positive, right? So it is missing the big chunk of information about the data. But if the original data does not follow at all the normality or the distribution, then in that case, you can say that you can still use the Sine test, but it is still useful in some cases when no other tests are possible. Okay.